And how do you get these peanut-shaped asteroids coming together? How does that happen? And this is their own words. It's a major mystery how two objects, each the size of skyscrapers, could collide without blowing each other to smithereens. And it's especially puzzling in a region of the solar system where the gravitational forces would normally include collision speeds of 4,500 miles an hour. 4,500 miles an hour, and yet they're coming together gradually. You ever wonder about that? I mean, they do. And how about these rounded boulders in Comet 67P? And there's that science thing up in the left. It says Comet close-up reveals a world of surprises. Yeah, rounded boulders in space. How do you get rounded boulders? Because if they collide, it's going to be sharp edges, not rounded. Okay, and why do you have stuff from the found on Earth in comets? Stuff like water, silicates, limestone, cubonite, olivine, organics, bacteria. And cubonite has to be formed in scalding hot water. Limestone has to be formed in water. How does that happen? I mean, where's the water in the solar system, especially scalding hot? I mean, Earth is the water planet. Okay, how do you get sea plankton found on the International Space Station? How did it get there? How did space plankton get into outer space, or sea plankton? Okay, and how do asteroids get moons? It's really hard to catch a moon. I mean, they've got 4 theories to explain the Earth's moon. And one of the guys says the best way to explain it is observational error. It doesn't exist. And so, because if things are coming together, they're going to accelerate and slingshot by each other, or else they're going to collide and blow each other apart. How do you get asteroids with moons? And this one has 2 moons. And you can listen to Kevin Lee talk about this, because some of the stuff was going with such tremendous force. Not only did it leave our atmosphere, it left our gravitational pull and just kept on going. And then the big rocks would attract the water and the carbon dioxide, the dry ice, and it would come together. And you got this stuff like dirty snowballs flying around. What's described as a dirty snowball? That would be a comet. Comets, and you can listen to this. Go into rsr.org and search Kevin Lee, and you'll hear about how he talked to Dr. Brownlee, the head of the Stardust mission, and he's going to say, you know what, you're going to find stuff from Earth. And that Brownlee is more like, no, what's this from the Oort cloud? It'll be from the outer solar system. And they were just shocked when they found the stuff that came from Earth. So I encourage you to listen to that. Or he spoke at our Creation Club also. Go and watch that on Rumble, TCCSA, The Origin of Comets and Asteroids. And so basically it just shot out with tremendous force, kept on going. The meteorites, the asteroids, even the trans-Neptune objects. If they come together like the evolutionists think, it should just slam apart. Okay, like playing pool. But if they're going the same vector, the same velocity, coming from the same spot, they come together gradually. They may be going really fast, but compared to each other, they'll come together gradually. That's how you get peanut-shaped comets. That's how they came from the same spot, going about the same speed. That's how they could come together gradually. How do you get rounded boulders in Comet 67P? Well, the only way you get rounded boulders is if it's going through a fast flow of water, I'd say in the subterranean chambers, breaking off the sharp edges before they get shot into outer space.